In this tutorial series, I'm going to answer the question, is it possible to solve differential equations using Julia without actually knowing anything about differential equations? I've never taken a differential equations class, but I do know a little bit of Julia, so I'm curious to find out if I can learn how to solve differential equations simply by learning how to use the differentialequations.jl package. If I can learn it, then so can you. So what do you think? Is it possible? Well, let's find out. Welcome to Doggo.jl, where I explore the vast Julia wilderness and turn my discoveries into wholesome Julia tutorials. If you go to the Julia Hub website, you'll see a list of the top Julia packages ranked by the number of stars in their respective GitHub repositories. You can skip DuckDB, because that's a Julia wrapper to a C++ library. The stars shown there are for the C++ library and not for the Julia wrapper. As of this recording, the number 1 Julia package is Pluto.jl, and the number 4 package is differentialequations.jl. Both of these packages have very interesting origin stories and were created by some unusually gifted members of the Julia community. Differentialequations.jl was created by Chris Rackauckas. He presented an early version of his package at JuliaCon 2017, while he was still a PhD candidate. I think it's fair to say that Chris is a legit rock star within the Julia community. He's probably the best known Julia developer outside of the original founders of Julia. He obtained his PhD recently, and he now possesses at least 3 different job titles at 3 different organizations. In addition, he somehow manages to have at least 2 YouTube channels that I'm aware of. It's not clear to me how he can be so productive, but he must be pushing the upper limit as to what's humanly possible in a 24-hour day. Not to be outdone, the Pluto.jl package was created by Fons van der Plas and Nicholas Bochenski. They introduced Pluto to the world at JuliaCon 2020, and shortly thereafter, their creation became the number 1 package in the Julia ecosystem. As a caveat, the Pluto package is partially written using HTML, CSS, and JavaScript, so it's not a pure Julia package per se, but Pluto was created to be used exclusively with Julia. Both differentialequations.jl and Pluto.jl are impressive accomplishments created by unusually gifted developers, so that alone is reason enough to pay attention to these packages. But why bother learning differential equations? Isn't that just some obscure branch of math that you'll never use? I've made it this far in life, and I've never had a need for differential equations. Or so I thought. It turns out that differential equations is the language of the universe. Whether you realize it or not, differential equations are everywhere. They define how things change relative to something else. For example, they explain big things, like how planets move over time. And they explain little things, like how the number of cells grow over time. By understanding differential equations, you can model the world around you in order to make predictions about future events, and sometimes even past events. If you want to gain a better understanding about how the universe works, you need to spend some quality time with differential equations. Okay, so hopefully you're convinced that differential equations is a subject worth pursuing. But why use Pluto to learn it? Pluto is a unique programming environment that's ideal for smaller projects that require experimentation and exploration in order to gain a deeper understanding of a subject. Pluto comes with a set of tools that allows a user to focus on learning new things without having to know much code. Because this programming environment will be so crucial to our learning process, I will be spending the first 3 episodes just covering how to use the Pluto Notebook. With that said, let's get started. No prior knowledge of either differential equations, calculus, or linear algebra is required for this series. Prior knowledge of Julia will be helpful, but you only need to know the basics. With that said, I do have a Julia for Beginners playlist available on this channel if you're interested in learning Julia in more detail. This series is not meant to be a substitute for an actual differential equations course, but by the end of this series, you'll understand the basic concepts regarding differential equations, so you'll be able to make an informed decision about whether or not you might want to pursue this subject further in a more formal setting. For these tutorials, you will need access to either a desktop or laptop computer with an internet connection. For your web browser, you will need to use either Firefox or Chrome. I will be using Firefox for these tutorials, but feel free to use either browser. I'm using a Windows PC, but you should be fine using either Windows, macOS, or Linux. In fact, the Pluto documentation states that Pluto should actually work better on macOS and Linux. Okay, let's start installing things. If you already have the latest version of Julia installed on your computer, you can skip this step. Start by going to Julia's official website at julialang.org. Select the Download button. Before downloading, I want to point out that there's a privacy note at the very bottom of the page stating that Julia's Package Manager server retains your IP address for up to 31 days. I'm guessing this isn't an issue for most of you, but this may be relevant to those of you with privacy concerns. As of this recording, the latest version of Julia is version 1.8.0. For my installation, I'm going to use the 64-bit installer for Windows, but pick the appropriate installer for your operating system. After the download is complete, run the installer. When running the installer, you can check the box to add Julia to path if you want to use Julia in your terminal window. We will not be using the terminal window for this tutorial series, so checking this box is optional. After the installation is complete, you should see a shortcut icon for the Julia REPL on your desktop. Double-click on the icon to open the Julia REPL. This is optional, but you can right-click along the top bar and select Properties to modify the display. Test the REPL by printing a Hello World message. You can also try 1+1. Okay, everything looks good. The next step is to add the Pluto package. In the Julia REPL, enter the package manager by hitting the closing square bracket. Add the Pluto package. For those of you with a Julia background, we're adding Pluto into the main environment, so there's no need to activate a working directory. Once the installation is complete, you can check the version number by typing in status. Hit backspace to exit the package manager. In order to launch Pluto, type in import Pluto. Once that's done, type in pluto.run. Don't forget the parentheses. Pluto should launch the default web browser on your computer. In my case, it's Firefox, but as stated earlier, you can use either Firefox or Chrome. You should see a Welcome to Pluto.jl page. There are several very helpful getting started tutorials included on this welcome page that you can check out at your convenience. For now, let's create a new notebook to see what this environment looks like. You should see a blank notebook with a single cell. Before getting started, here are some life hacks. These life hacks are not part of the official Pluto documentation. But since Pluto is written using HTML, CSS, and JavaScript, you can hack it just like any other website. The default theme on my browser is the dark theme. You can change that by going into your browser settings and changing the theme. I'm going to stick with the dark theme. You can toggle the full screen display on your browser by using the F11 key. You can zoom in or out by using Ctrl+ or Ctrl-. Now, when I zoom in, the cell is no longer centered and is now aligned to the left, which may or may not be what you want. At the bottom right of your display, Pluto provides a handy way to look up inline documentation. While this may be convenient, on my monitor, it's taking up a lot of valuable real estate on my screen. There's currently no way to customize this view in Pluto, but just like any other web page, you can modify the styling by right-clicking on the screen and selecting the Inspect option. In the Inspector tab, along the left-hand side, look for the main element inside of the body element and click on that. In the middle box, you should see some styling options. Uncheck the Align Self box. The cell should now be centered. Go back to the Inspector tab and look for the Aside element, which should be immediately below the main element. Again, in the middle, you should see some styling options. Uncheck the box for Display. Once you do that, the Live Docs tab should disappear. Now don't worry, none of these changes are permanent. You can turn them back on at any time. Pluto will also return the default settings the next time you load this notebook. You can get out of this Inspect panel by clicking on the X at the right-hand side of the menu bar. Now that we have our notebook customized to our liking, let's test it out. Let's try our standard Hello World test. In Pluto, there are 3 different ways that you can execute the code in a cell. The first option is to use the Run Cell arrow button located at the bottom right corner of the cell. When you click on that arrow, you should see an output with Hello World below the cell. You can add a new cell by using the plus button at the lower left corner of the cell. You need to hover over it in order to see the plus button. You can delete a cell by clicking on the 3 dots at the right of the cell, where deleting a cell is one of the options. Again, you need to hover over it in order to see the dots. In general, when using a notebook, you should avoid using the print line function. Instead, you should use markdown text by using MD immediately followed by quotation marks. The second option for executing code in a cell is to use Shift-Enter. Shift-Enter is the keyboard shortcut for the Run Cell arrow button. You should now see Hello World displayed above the cell. This might take some getting used to, but in Pluto, the cell output is normally displayed above the cell and not below it. Add a new cell by using the Add Cell Plus button. This time, try 1 + 1. The third option for executing code in a cell is to use Control-Enter. Using Control-Enter will execute the code in the cell and then add a new cell immediately below it. For the most part, I'll be using Control-Enter in order to execute the code throughout this tutorial series. You can see a complete list of the keyboard shortcuts by hitting F1. Next, I'm going to show you some of the basics of using Pluto. But first, an important message from our sponsor. Hey coders, has this ever happened to you? Ugh, what am I doing wrong? Help me, Debuggo Doggo. Oh, it's printline, not printline. Thanks, Debuggo Doggo. You're the best. Debuggo Doggo won't actually debug your code. I'm going to spend the next 2 episodes going into detail about how to use the Pluto Notebook environment. But here's the quick crash course version. In Pluto, you can use Markdown, LaTeX, and Code. The Notebook programming environment is basically a digital version of the traditional paper-bound lab notebook, so one of its strengths is its documentation capabilities. As a result, you'll be using a lot of Markdown in the Notebook programming environment. Let's add a new cell to the very top of this notebook by using the plus button at the upper left corner of the top cell. As you saw earlier, you can use Markdown by using MD, immediately followed by quotation marks. This time, I used Shift-Enter because I didn't want to add a new cell. Using a single hashtag will create a header using the largest available font size. You can hide the cell containing the code by clicking on the eye icon at the left of the cell. You need to hover over it in order to see the icon. I have a video on this channel where I cover Markdown, but the Markdown used in Pluto is slightly different, so I'm going to cover how to use Markdown in Pluto in more detail in the next tutorial. The other primary purpose of a digital notebook environment is to capture math equations. Pluto supports LaTeX syntax, which you can use inside of your Markdown by placing the LaTeX code inside a pair of $signs. As you can see, the math equation is displayed in the familiar, highly stylized math equation font that you may recognize from any math textbook. Again, I have a video on this channel where I cover the text syntax using KaTeX, but the LaTeX syntax used in Pluto is slightly different. I'm going to cover the LaTeX syntax in more detail in the next tutorial, so don't worry if you don't know it yet. Consider this a preview of coming attractions. Finally, you can enter Julia code in the cell. In Pluto, it's best to have only one line of code per cell. Now, watch what happens when you try to reassign a value to a variable in a new cell. Your screen should have been lit up with warning messages. That's because the Pluto environment is quote-unquote reactive. In a reactive programming environment, you can only reassign a value to a variable in the original cell containing that variable. Delete that last cell, and then change the value of the original cell, and then hit Shift-Enter. Did you see what happened? The value of Z changed automatically. For those of you coming from a spreadsheet environment, you may not think that this is anything unusual. But for those of you coming from a coding background, you should immediately recognize that this is very unusual behavior for a programming environment. And if that isn't enough to blow your mind, you can also rearrange the order of the cells, and it will still work. That blank space along the left-hand side of your screen is not white space. They are handles that you can use to drag and drop the location of the cells. Again, for those of you coming from a coding background, you might find this feature to be unsettling, since this is not how a typical programming environment works. When using Pluto, it's important to understand that Pluto is a unique programming environment that may take some getting used to. But fear not, Over the next couple of tutorials, I'll cover all of the basics, so by the end of it, you'll be completely comfortable using it. Finally, let's see how to add a Julia package when using Pluto. Pluto comes with its own package manager, so there's no need for you to use the Julia REPL. All you need to do is type in using and then the name of the package, and then Pluto does everything else for you. Each Pluto notebook is its own self-contained environment, so there's no need for you to worry about isolating it manually. Once it's loaded, let's generate some random numbers to use in our plot. Pluto provides a handy way to view your data. Now, let's use the plots package to plot this data. Pretty cool, right? Now that we've created a sample notebook, let's take a look at the various saving options. If you scroll up to the top of the notebook, you can click on those shape icons in the top right corner to reveal the export options. You can save your notebook as either a .jl file, an HTML file, or a PDF file. I'm just going to save it as a .jl file. You can try those other options at your convenience. After saving your notebook, you can close it simply by closing the browser window. As you can see, the REPL is still running in the background. I haven't figured out how to close this session. You're supposed to use Ctrl-C, but it only works for me if I hit Ctrl-C multiple times. Before we go, let's take a look at the actual .jl file using VS Code. We're not going to be using VS Code in this tutorial series, so don't worry if you don't have VS Code installed. I'm just using VS Code for this demonstration. Technically, this Pluto notebook file is a .jl file, but it looks very different from a standard Julia file. As you can see, Pluto added all sorts of code to this file. Each cell has a unique identifier number. And down at the very bottom, Pluto has included the code that would normally be included in a separate project.toml file and a manifest.toml file. If none of this makes sense to you, don't worry about it. This will only make sense to those of you with a Julia coding background. I'm just showing this file to point out that even though the Pluto notebook was saved as a .jl file, it's not a typical Julia file, and it will only work inside of the Pluto environment. Interesting, right? Okay, let's recap what we accomplished today, and then take a quick peek into the next few tutorials. We started by getting a high-level introduction to the subject of differential equations. We were then introduced to the developers of the differentialequations.jl package and the Pluto.jl package, which are two of the most popular packages in the Julia ecosystem. After installing the latest version of Julia, we installed Pluto and created a simple Pluto notebook and learned some of the basics for getting around this unique programming environment. Over the next couple of tutorials, we'll dive deeper into the details for how to use Markdown and LaTeX in Pluto. We'll also dig into the details for how to write Julia code in Pluto, and we'll also learn about some special tools that come included with Pluto. The differential equation section won't start until episode 4, so if you already know Julia and already know how to use Pluto, then you can skip the next couple of episodes. For those of you who are new to Julia or new to Pluto, I'll see you in the next episode. If you made it this far, congratulations! If you enjoyed this video and you feel like you learned something new, then please consider smashing that like button, leaving a comment, sharing this video, and subscribing to this channel. If you'd like to support the educational work that I'm doing, please consider making a purchase at the Doggo.jl online store. You can browse through a wide selection of Doggo.jl merch by clicking on the Store tab. For one-time donations, please consider using the Super Thanks button. For ongoing support, please consider joining and becoming a channel member. Channel members get early access to all of my new videos. Early access videos do not contain YouTube ads. New tutorials are posted on Sundays/Mondays. Thanks for watching, and good luck on your Julia journey.